think we're ready to get started. Streaming Advent of Code, day 13. Let's first get set up, make sure I'm all up and running and everything's going well. Let's see, mod 13 for today, and add that down here. Double check that it fails. Good. And then we're gonna do our usual rigmarole with the makedir. And we are going to edit source mod day 13 mod.rs. Hub fun day 13. Put that out. And go. Good. And if we run it, we should see day 13. Oh, right. Day 12 takes a long time. That's going to be annoying, isn't it? It takes 5 seconds to run day 12. I want to just comment that out. Or maybe we can just reverse the order. That way at least we can see the output right away and not have to worry about warnings from commenting out code. Let's reverse these guys. Because I'm guessing between runs we're going to need more than 5 seconds to fix something. Okay, so we have day 13. Let's take a look at our calendar and see what the problem is. Day 13, transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently the elves never used this feature. To your surprise, you manage to find the manual. As you open it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots and includes instructions on how to fold it up, your puzzle input. For example, this. Okay, fold along y is 7, fold along x equals 5. The first section is a list of dots on the transparent paper. 0, 0 represents top left. Okay, yep, I get all that. The coordinates in this example form the following pattern where hash is a dot on the paper and dot is empty. Then there is a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up or left. So we're always folding up or left. In this example, the first fold instruction is to fold along y is 7, which designates the line formed by all of the positions where y is 7, marked here with a minus. Okay. All right. Let me take 2 seconds and grab something. Hang on. Back. Let's see, where were we? Right, so we're folding along this line here. And because this is a horizontal line, fold the bottom half up, right? Some of the dots might end up overlapping after the fold is complete, but dots will never appear exactly on a fold line. The result of doing this fold looks like this. Now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before the transparent paper is folded. These 2. After the fold is complete, these appear in the top left corner at 0, 0, and 0, 1. Okay, right here. Okay. I think I understand the problem description. Also notice that some dots can end up overlapping. In this case, the dots merge together and become a single dot. Here's a fold along X and it becomes a square. Transparent paper is pretty big, so for now focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. Okay, how many dots are visible after completing just the first fold instruction? So what is our table? That's pretty big. We're in the thousands. It's a big piece of paper. And then how many fold instructions are there? Not too many. All right. So let's start by creating test input. We will, where are we? We can go here and say edit, no, inputs, test, day 13, paste that in, save that. Oh, inputs, right. Test day 13. There we go. Okay, then let's switch back to our source day 13 code. So step one is forget how you do the reads. Edit source day 12 and then copy that line, put it here, and then copy this line and put it here. I'm never going to learn if I don't actually type it in myself, but that's okay. Create utils read file. Let's see if I can remember that for tomorrow. So now we're going to loop over the lines. And now we can't get the width and the height from the file, right? We actually have to compute it. So let width equals 0. And we compute it just by finding the largest one and then adding 1 at the end, right? Let's go with each line. We're going to say let the x position and the y position in string form is going to be l.split once of that. Then we're going to say let x equals and we're gonna do a grid of in the past in the previous exercises we did grids of just arrays of U8s or whatever. This could be an array of bools, right? Because we're just keeping it this way. But to change things up a little bit, let's make it a hash set of I32, I32. Width is U size and the height is a U size. Hi Modprog, welcome to the stream. Have you done this puzzle already? Oh, I'm not showing anything. Oh man, thank you. Thank you. All right, so all I did was set this up, and then I read the whole description blind. Sorry about that. I'm a pro streamer. Did you know? I'm not really a pro streamer. Okay, so shake that off. Stir x dot parse. Oops, parse unwrap. And then y is just stir y. Unwrap. And then what we do is insert into a grid. We'll create a grid. And just say grid dot insert xy. Oh, we can't just do it for L and lines. We actually have to stop at a blank line. So we'll start there and we'll say while lines of idx is not blank. We'll do this and we'll say idx plus equals 1. Oh, split once. Split once I just learned about yesterday, so, and I think it might be an option. Rust string split once. Or C split off. Here's split once. Yeah, it returns a sum. Okay. So this has to be a sum of this tuple. going to say if let sum. Okay, at this point we should have a grid. So let me implement a print function for the grid. For x, no, for y, we always start with the rows. 0 dot dot width for x and 0 dot dot. What am I doing? Self height. Self width. If self grid contains xy, print just the hashtag, otherwise we print a dot. And then at the end of that, println to get a blank line or a new line, and then we're done. So up here what we can do is say let grid or paper. This is a paper. It's a new grid of grid O. You know what I forgot to do is set width and height. So if x is greater than width, oh, except these are going to be, yeah, they're all U sizes, except these are I32s as U size. Width, and width is x as U size. If y as U size is greater than height, then width height is equal to y as U size. All right, and then this is actually not the width and the height. This is the highest x and the highest y. So in order to get the true width, we have to say width plus 1, and height is height plus 1. And then we can say paper.print. And let's see what blows up. I misspelled collection. Oh, is it collections? And we don't have split once. Oh, can't find L. Lines of IDX. There. And expected I32 found U size. Oh, down here. Okay. That's going to get annoying. When we do the folds, we're going to have to keep flipping back and forth between U size and I32. All right, let's print that grid out and see if it looks close to what. Nope, that doesn't look anything like the grid that we're supposed to see. Did width and height end up being 1, 1? I set them to 0 here. Wow. What the heck did I do wrong? Yeah, it looks like we just ended up with 1 and 1, which means width and height ended up being 0. Oh, maybe it just, these never, oh, split one's dash? No, split one's comma, right? We're looking at comma split data. Okay. All right, let's try that again. Okay, that was an easy bug to fix. This looks correct, right? We see the 3 across the top and a little L down here at the bottom. And so that's good. What we need to do now is implement, well, we have to do two things. We need to parse out the fold commands, and we need to implement the folds. So our first fold is y is 7. So let's implement, this might get annoying, right, to implement it both ways, but a lot of extra code. Fold y. We're going to mutate ourselves, and we're going to fold it along the y position. All right, so now we're always fold up, they said. So if the y position is down here in the top half of the thing, right, less than halfway, then the bottom row is going to fold up over the top row and come up higher than it, right? So this becomes the new 0. If the fold is down here, then this is going to fold up into here, and row 0 through whatever remain the same. So we might have to check. We might have to do, well, let's do that and see what the code looks like and see if it can be made into common code using subtraction and absolute value and all sorts of mathy stuff. Let's check for now. If y pos it's less than, what are we actually doing? We have a, what's the highest? 13 here. So we have a height of 14. Yeah, 0 to 13. So we have a height of 14, which means 7 is going to be halfway. I'm just trying to see self.height over 2. I'm just trying to see which one we have to implement for y equals 7. We'll do that one first. What other examples do they have here? Oh, they just have the x equals 5 example, and that's it. All right, well, let's do this. If y pos is less than self height, then the bottom row becomes the new 0. And here the bottom row, top row, stays at 0. So let's just draw a little map of 1, 2, 3, 4, 5, 6, 7. Maybe we'll do one that's 8 high. So the height is 8. So we'll say starting height is 8. And then what if we do a fold right here? What happens to this? Each one of this become, if we're folding here, then row 2 becomes the bottom row. Right? So it stays at 2. Oop, I don't know why I typed 3. I was just trying to get the tab right, so I can tab over here. Oh, and it doesn't stay at 2. This becomes the bottom row, whatever the bottom row is. This becomes 0. Right? The bottom row becomes new 0. For this becomes 1. This becomes 2. This becomes 3. This becomes 4. So this becomes row 5. And then this becomes 4, right? Because it folds up. And this becomes 3. So it looks like the new height is 6. All right, so if the height here is 8 and we fold it 2 and the new height is 6, then we can actually calculate the new height pretty easily, right? New height equals the self height minus the y pos that we're folding at. And then each of the locations just fold up. So it's just the absolute value of the difference, minus 1. Right, so 2 becomes 5 if we fold at 2. And 5 is 1 less than the height minus the fold value. So it might be that simple. Let's just do it and see. For y in 0 dot dot height, for x in 0 dot dot width. So let me make this window bigger here. Okay. Let's see, let new y equal the self height oh no, first we have to see if self grid contains xy. X as I32, Y as I32. So if it contains it, then we have to adjust the Y value. And what did I say? It's the original height minus that, and then we want to do absolute value. So I32 abs self height as I32 minus Y pos as I32 minus 1. So does that work for that works at the fold, right? Does it work here? So height is 8. we subtract 1 and then subtract 1 more. No, that does not work. We can start it at the y pause. Why don't we start at the y pause as I32, and then if we subtract the y value that we're on, so it's actually, yeah, what I was thinking of subtracting then y minus y pause. I'm just doing this temporarily here because I got to add I32s, but that's the same thing as, right, because if y pause is 2 and y is 0, y minus y pause is negative 2, right? So we add that to y pause and we get 4. So that doesn't work? Ah, math is killing me here. So this is y pause. If y is 0, we want this to be 3. So it's 2, right? It's the 5, which is our new height, minus the 2 of the fold. And that becomes 3, and then we add, why is this hurting my brain? Let me just try this. Y pause as I32 minus I32 abs. Y is I32 minus Y pause as I32. I think that's where I'm going with this. And then we're going to create a new grid. And down here, we'll just say new grid dot insert x as I32, because x doesn't change, and then the new y. All right. And what we can do here is just set this less than or equal to height, and I'm going to say paper print, paper, without doing the parsing. I just want to see if this fold, if we're close on the fold. Paper and print. Great. Folded 7. And of course it doesn't check. Let's see if we can figure out how to get this to compile. Oh, colon new. Oh, self height and self width. Oh, fold, what do I call it? I call it fold Y. And I didn't make it mutable. Okay, still have 2 warnings. Okay, we folded it. Oh, you know what I forgot to do is just update it. So after we're done, let's pull this out because I want to be able to update the grid and the height. Let new height. And then just set it here, and then we can set it in the other side. What would this new height, if the top row stays at 0, then the new height is just equal to y pause plus 1. Right, because if the top row stays at 0, then the new height is whatever we're folding it at plus 1. And then we can say here, self grid equals new grid, self height equals new height, and then we're done. Ugh. And of course I misspelled it. H-E-I-G-H-T. Run. Ah. There. What am I doing? H-E-I-G-H-T. Holy crow. Okay. It folded at 7, and it looks like I did the right thing. If you compare this to this, right? I see the doubles, I see the triples, I see 111. All right, so that code worked. And I think I just got lucky with the whole XY stuff. So let's redo this for folding the other way. In this case, the Y pause is. So let's change these all to spaces, and now we're going to fold the other way. So we're going to fold it 5 here. And this becomes the new Y pause. And how do we test this, right? Because I don't know if we're going to get it right if I do this. Well, I guess what we can do is just fold. Oh, I can fold along this line here, right? What they said was that every fold line has no dots in it. It said that somewhere, right? I just want to double check that I didn't make that mistake. Some of the dots might result in fold. 2 dots in the bottom left. I thought I remember seeing that. I just want to double check. I mean, it shouldn't be a big deal if we fold it along the thing with the dot. We'll look for the word fold, but of course that's not going to help. In this example, right? Here it is. Dots will never appear exactly on a fold line. Okay, that's what I was looking for. All right, so what it means now is that all these stay the same row. 1, 2, 3, 4, 5. And we're folding at 5, and then this becomes 4, and this becomes 3. So it's exactly the opposite of this guy here. Our new height is 6. Still, because I did the offset by the same amount. Our new height becomes different, is Y pause plus 1. But can we reuse this code? Let me just for fun, let's see if reusing this code works. And what I'll do is I'll try to fold on, instead of on 7, I'll fold on 9. And that should get us through this code here. And then we can just manually do it. So this is folded at 9, which means this becomes, oops, on the bottom row. Oops, that's hard to do. This line should go here. Right, this if we fold here, this line goes here. Right, and then this line goes one above it, right here. Yes. And this line goes one above that, right here. Right, so this is 9, 8, 7, 6. Wait a minute. This is right. That's right. Oh, okay, so this line here is the one that changed a little bit. It got these 2 bottom ones up here. I think that's right. Right, if we fold it at 9, that means there should be 10 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And what I'm confused by is, okay, that guy's there. That guy's here, right here. And these 2 got folded into here. Okay, so it's actually the same code. So if we can do that, right? All we need to do, we can factor this out to here. And all we need to do is say let new height equals this, else this. And I'm going to leave the comments in there just for my own sanity. And if this doesn't check, oh, semicolon. Oh, we're not returning it like that. We're just setting it like that. Okay. And then let's see. This will run on a fold of 9. And I think that's still correct. Let's just do a fold of 7. And I think that should still be correct. Oh, I got to leave it so I can see it. I have a... Otherwise it'll all merge together. Let's stop it. Let's expand this. And then we just need to write it for fold X. And then we need to write the parser. All right. Let's do fold X now. And fold X is going to be similar, except it's going to use XPOS. Let new grid equals hash set. And it, we might be able to extract out common code. Let new height if XPOS is less than or equal to self width. Oh, not new height, new width over 2. We're just going to steal the same code here. We're going to say self width minus XPOS, else XPOS plus 1, semicolon. And then we're going to steal this code and change the y's around to x's. So this will be new x. It's going to be XPOS, blah, 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 x as I32, x. And this is going to be new x and then y as I32. We will update self grid. Self width is the new width. Is that all we need to do for that? We get a warning that we're not using it. What did I do? Oh, semicolon there. Width. I'm trying to type too quickly to try to get this done. Right, so we're not using fold X, but we can. And we'll just say folded at y equals 7, folded at x equals 5. So paper.fold x5, paper.print. And let's run that and see if we come up with a box. We do. All right, so that works. But I'm only testing one of the fold branches, which is frustrating to me that we don't have data for that. But the last thing we need to do now is parse out the instructions. And the instructions have the form fold along y equals 7, fold along x equals 5. Okay, so we can say for, so we can say while idx is less than lines len. Now I can't do a split once. Let mut split equals lines of idx split on white space. And then we'll say split.next, split.next. That's the fold, the word fold. This is the word along. And then we can say let if let sum stir x stir axis and stir line equals split dot next dot unwrap dot split once equal sign. Then println fold along equals that, and we will say axis stir line. We'll just print those out and see if we got those correct. We got warnings because we're not using a bunch of stuff. That's okay, and we panicked. We unwrapped on a none. 138. But I have an if let. Oh. Println. This should be fold, right? Oh, I know what happened. We have to increment past the blank line. Skip blank line. Okay, so we can get rid of these now. Okay, let's do this. Oh, and of course, yeah, I don't know how to kill this. I guess I do. I hit Control C enough times. I forgot to increment index. Okay, so that worked. So now we just say if axis equals, first we have to convert the number. Strline, and this is USAS. Parse, unwrap. Axis is X. Then paper fold X on num. Else paper.fold Y. No. We always assume the input is perfectly valid in Advent of Code. We don't have to check if it's a Y and then reject errors. Oh, and then we got to print it out after we're done. Paper print. Okay, so we got the square. Except we have a bug. Oh. Yeah, so the bug that I'm looking at is the fact that this has one extra dot along the bottom and one extra dot along the side. So that means that the fold goes away. So this is actually just, let's just subtract 1 here. Or, yeah, we can just get rid of this and say subtract 1 here. Because we don't actually use new height to calculate the new grid. And we'll just subtract 1 here. We'll do this. Keep things the same. All right, so let's run this. Okay, so now this actually looks like the grid we're looking for. And we also need a thing which counts. Actually, we don't need a thing which counts. We can just print out. We can ignore the print because this test data is huge. Let's save it. Day13.txt. Move document the downloads. Input day13.txt into inputs. So I don't want to actually print it because this is going to be huge. You can see that these numbers go into the thousands. But I imagine once it's all folded up, it'll be nice and small. So we still want the print eventually. I guess we can print it out, but right now all we need to do is do the first one. For part 1, we need the first one. Let me close this. So for part 1, I'm just trying to think of how to just determine we did part 1. So let not did part 1 is false. And then we say here, if we didn't do part 1, what we can say is print Let me switch this back to here. We can say println day 13 part 1 is going to be just equal to paper.grid.len. All right, and then let's do the test. We're still with the test input. We should see day 13 part 1 is 17. Oh, and then we got to say did part 1 equals true. It's kind of a sloppy way to do it, but I'm going to go with it. And we got part 1, 17. We don't have too many instructions, right, for folding. Day 13. Yeah, there's only a few of them. So I can still print them out. I'll still print them out. I'll leave this line in here. And then we can take it out later. All right, so let's go with the real input and see what blows up. Oh, and this might be part 2, doing all of them. Right? Because I see letters here. So we might have done both parts. That's the right answer. Finish folding transparent paper. Manual says it's 8 capital letters, CJCKBAPB. Boom. Wow. I think that was the fastest part 1 to part 2 I've ever done. Let's look at my stats here. Look at that. I could have done it even faster. It took me 11 seconds to type that in. How bad am I? All right. And we still didn't crack the... okay. So this isn't too bad. This isn't too bad. The only thing of you know what would be neat, you know, if I had time, we could do like character recognition kind of stuff, and you know, do OCR this thing and just generate the string. That would be kind of fun. Println day 13 part 2. It's just this, and we'll do paper print. And then we're going to get rid of the fold commands because those all worked and we're all good to go. Let me cargo run this one more time. I still have 12 coming after. What I should do actually is spend a little time optimizing 12. I'm not going to do it now. But it'd be nice if we could do that. Even this takes over a second to complete all those folds, generating all those hash maps and folding them around and stuff. All right. Yeah. I mean, is there anything we can do in terms of? I think we're good. What about commonality of code? I think the only difference between, yeah, both of these use this same function, except, you know, ypos versus xpos. And I don't think there's an easy way to make this parameterizable. Yeah, I think I'm going to leave it there for day 13. And there was no part 1 versus part 2 because I did all of part 1. Part 2 is part of part 1. So git add source and inputs. Git commit. Item day 13 both parts. Git push. All right, that is day 13. Let me take a quick look at day 12 and see if I can think of any way to make this go faster, because it takes 5 seconds. Cargo run release. How long does it take in the release mode? It still takes almost a full second in release mode. So it's super slow. And when you compare it to the other ones, what's the other longest one? This is the one we just did at less than a tenth of a second. And then day 5 was very quick too. Yeah, this is, it's bugging me that this is so slow. But I don't know how to make it faster because I am not an optimizer person. So yeah, so this is the function count visited from for day 12. We're just doing a depth first search on all these nodes. Oh, yeah, I do know that there is something we can do to make it faster because I'm calculating the same path multiple times. And I cheated by putting in a hash set so that we had unique paths only. So it would be faster if we could just generate unique paths from the get-go and not have to uniquify them by throwing them into a hash map. And it's probably got to do with the way I'm doing this thing. So right now we pass in a string of what whether or not we're going to visit that cave more than once. But can we just do it in down here? Can we set a flag saying, okay, we've hit this guy, now flip the flag to false and then hit him again? I'm gonna have to think about how to speed this up, and maybe in tomorrow's, if tomorrow goes as quickly as today's does, I'm gonna spend a little time thinking about the right approach to this, and then maybe on stream we can try to implement it. But I can't think on my feet right now. So, all right. We have about a half an hour. Oh, thank you, ModProg. I missed your follow. Thank you for the follow.